Hello everyone and welcome to the video. In this video we'll be looking at packet and how to use it for F#. Okay, so what is packet? Packet is a package management tool for F#. I'm sure if you've used F# for a while now, you'll know what I'm talking about. And for this video, I'm going to assume you know what package management is. There's probably a lot of content on the internet to know what package management is. For the sake of this video, I'm just going to assume you know what I'm talking about. So why use packet? Because I'm sure if you've used .NET in the past, you're used to using NuGet, and you'd be wondering why the hell would I not use NuGet? And that's a pretty good question, a question that I asked myself initially. But let's compare the two and see why packet was actually created in the first place. So NuGet is also a package management system for .NET. It works on .NET Core and .NET Framework. So packet is written on top of NuGet, which is a pretty important thing to note. So all the NuGet packages that are created in .NET are still reusable with packet. The goal of packet was to solve a few problems at the time that NuGet did not handle, and that some of them were F# specific problems. So let's go over the main reasons why packet was created and comparing them with NuGet and see if it still makes sense to use packet today. So firstly, when we use packages for a given solution, let's say there's many projects in the solution, normally what you would want is you'd want the same version of a package used in all those projects. And the problem at the time with NuGet is that NuGet manages versions per project. So the way it works is, let's say in two projects you want to use system.valueTuple or something like that. You'd have to manage the packages per project, and there'd be a packages.config, and let's say you need to update a version, then you'd have to think about updating all versions, or else you can have like problems with one project uses one version and another project uses another version. And then trust me, if you have a lot of projects and let's say you're using Newtonsoft JSON, you're gonna find yourself finding weird bugs from time to time. So what packet does is that dependencies are defined in a global root level. So you say what dependencies you want, and then per project you refer to those dependencies. So let's say project A needs Newtonsoft and project B needs let's say system.valueTuple. Then you have a dependencies file at the root of the solution that will say, hey, I need system.tuple and Newtonsoft. And in each of the projects you refer, so you have a reference to that dependency in the root level. So let's say if you want to add Newtonsoft to both projects, so it was only in one project and then you want to add it to the other one, now you just have to add a reference to project B, for instance, and you can be assured that both of the versions will be the same because you're not handling the versions and dependencies per project, you're doing it per root, and then you refer for each project. So that's one of the issues, and obviously you can handle this with NuGet. You can handle the problem and do a workaround. Like when I was working at Genetech, we had a workaround where we would just put all the dependencies in one project and then you refer those projects to that main project. I'm not going to go too much into detail with that. But there's obviously ways around that, but it's just annoying, and this is one of the main goals they wanted to solve. Now the second problem we wanted to solve is the issue of transitive dependencies. So a transitive dependency is, let's say, a dependency of your dependencies. So for example, if I'm using Newtonsoft.json and Newtonsoft.json uses in its own package, it has a dependency towards system.text or something, or whatever. In your NuGet, in your packages.config file, in the NuGet system, you would have your dependency listed, but you also have your transitive dependencies listed. So that you'll have in the same file at the same level your transitive dependencies and your actual dependencies. And this makes it really hard to figure out what you're actually depending on directly and not what your dependencies the dependencies are. So one way to solve this is to have a dependencies file, okay? In Packet, how Packet solves this is there's a dependencies file where you list what you actually need, and then you have a lock file. That the lock has the version lock, so to make sure you have the same version every time, and below that it lists what are the transitive dependencies that it needs. So this way you can clearly know what you're actually referring to and what your dependencies are, or what are the dependencies of your dependencies. So this might not seem like a big deal, but if you have a lot of dependencies and you're trying to clean up, like what do I actually need, what I'm deferring on, maybe you want to reduce the size of of your DLLs or something like that. It's very useful to have a lock file. Now, one important thing to mention is that nowadays, or I don't know when it was introduced, but now NuGet can work with a lock file. So this is one of the problems, one of the issues that initially Packet tried to solve, and then NuGet came and then it changed it up to solve that problem. So if you're looking for a lock file type of system, now you don't need to really worry about that. The other thing to note is that since the inception of Packet, now we can have package references on .NET Standard or .NET Core projects. So you don't have to actually work with the old package.config system anymore with .NET Core. So that's another problem that was solved after the inception of Packet. That now, like, you can argue that you don't really need to use Packet because of this new system. Because you can just use the package reference system instead of the packages.config. And I know if you're new to this, it might sound very complicated, but these are nuances that maybe are more advanced, and maybe you don't really need to know the pros and cons of this. You just want to get in and do it. Don't worry, you don't have to really understand all these nuances. You can just, at the end, I'll show you how to use Packet, and you can use it that way. You don't have to really understand for now, because these are more like advanced intricacies of package management and software management. So don't worry about that if you don't really understand the pros and cons of this. Now, the third issue that Packet wanted to resolve is the package paths. So the paths on the file system with NuGet contains the version numbers. And the problem with that is in F#, we have the F# interactive scripting environment. And for this environment, you have to actually refer in the header, you have to do a special import directive to use packages and to use DLLs, which is very specific to the interactive part of F#, the F# interactive scripting environment. And the issue is, let's say you have to upgrade a dependency. Now you actually have to change code. You don't just change your fsproj or your packages.config. Now you have to change actual code, and that's pretty annoying. So that was the issue that Packet wanted to resolve, is to eliminate the version from the package path. Now, as I'm recording this in 2021, obviously, well, maybe not obviously for you, but obviously for me, F#5 was released with .NET 5. So one of the features that was released is now, instead of having to link the exact path of the DLL, you can actually have a NuGet directive in the F# interactive scripting environment. So you can just put the name of the package and it'll resolve itself. So this issue is also resolved. Even though Packet resolved it back in time, the language evolved, and we don't really need this new advantage that Packet offers over NuGet. The fourth advantage of Packet is, instead of linking NuGet packages in the dependencies file, you can actually link source files directly from GitHub. So let's say for some reason you would have to link to a source file directly, and there are instances of that. Let's say if there's a pre-compilation flags, so for the Fable compiler, or I ran into an issue where I would want to have code that be shared via like open source or whatever, but I would want it to be compiled every time a software is compiled. So I don't want this pre-compiled DLL, and I don't want to share that DLL. I actually want to share the source file because there are pre-compilation flags. So this is super cool, to be honest. You can just link the files directly and have them included into your code base. So this is a one win of packet over NuGet. It's just a nice to have feature. And lastly, and most importantly, why I would argue to still use packet is that it is very CLI driven. So a lot of the tools in F#, how they're designed is to work not in basically any IDE you want. Because in the C# .NET days, where I guess you can still, people still write C# a lot. The tools were more focused on Visual Studio and having an integrated, very integrated development environment. And with the F# kind of movement, the way that the community evolves is they work in VS Code. Some use Visual Studio, some use I use Rider. And having CLI-driven tools enables the use of those tools in any IDE you want. You can basically write in plain Notepad if you want. Obviously, that's a horrible idea, but you get the point. Not having a GUI or very integrated with Visual Studio software is very important in F# because the advantage and the let's say the idiomatic way to do things is to use the command line. So that's one big design feature if you want. Okay, so now that we talked about the problems that it tried to solve in its inception, if you listen closely, I noted that a few of these reasons why it was created were actually solved after the inception of Packet by NuGet. So in 2021, the question is, should you still use Packet for F#? And the answer is a pretty resounding yes. One of the big reasons is basically all the open source project uses it. All the F# developers use it. So it's kind of like why JavaScript is still around is because everybody knows JavaScript and you can just, it's kind of, it had so much momentum that people are still using it, even though you can argue there are better tools, better technology. Maybe you can argue not as well. But you kind of build around what's being used, and it's used a lot. Most open source projects are using it, as I said, and it has some cool advantages still over NuGet, I feel. So you should definitely learn how to use Packet in your projects, and we're going to look into how to get started and a basic overview of how everything works when I jump over the computer. All right, so let's get started. So first I'm going to start by creating an absolutely empty workspace. So we're just going to go sample for learning Packet. And is the font size enough? How do I increase this? Okay, hopefully that is good enough for a little bit of a zoom. So the first thing we're going to do is we're going to open a PowerShell window or a shell window, whatever you want to use. I personally use PowerShell. So basically the first thing we need to do is we don't have a solution yet, so we're just going to create a new solution. And of course you can use your IDE to create a solution. I'm just creating it with the command line for now. And I'm going to create a Git repository just because I want to show a few ways you can do things. So I'm going to open up source tree and I'm going to add a new repository. I'm not really used to using Git as a command line because I guess I never really needed to. Boom. So I actually just didn't select, I selected the Git folder instead of the root folder. That's kind of my bad. So I'm just going to give initial commit. Okay. And so the first thing we need to do if we're going to use .NET tools is we need a .NET tool manifest. So this is a file that keeps track of all the tools you have in your repository, because basically with .NET tools you install, you can either install them locally or globally. Most of the time people install them locally, so you need a tool manifest. So we're going to do .NET new tool manifest. This will generate a I'm just checking if you can see both windows here. Let me just do this. Okay, so yeah, this will create a .config, and it will create a .NET Tools JSON. And for now, I don't have any tools, so it's just empty. It's just an empty manifest. We'll see. We'll see more of that. And now that we have a manifest, we can actually go ahead and install packet. So we can go .NET tool install packet. So packet is actually a tool in .NET. So .NET, you can have tools that do a bunch of stuff. It's just a better practice than to have it as a package in your solution. It's just a lot easier. It's more idiomatic as well. And so this will install packet locally. If you wanted to install it globally, you can just add .g, I think, or it might be global. I'm not sure. I'm pretty sure it's just -g. But we're going to install it locally today. And cool. So now it's installed, and just to check, you'll see that I have packet here in my manifest. Cool. Now that we have packet installed, actually I open up the solution. So the first thing I'm going to do is I'm actually just going to add projects, because now we have an empty solution. There's no projects, so I should probably have done that beforehand. But we're going to go new folder. I'm going to do source, just because it's more common to do that. You don't really have to. It's just a way you can organize your work. So you're going to do new project. And can you see this right? Yeah. We're going to go console application. And you can just call it console app. It's going to be in the source folder. And we're going to use .NET Framework 5. So I haven't really talked about this yet, but since .NET 5, which was released in, I think, November, it basically consolidated .NET Core and .NET Framework. So now, even if we want to use .NET Core from version 5 on, it's just .NET. It's just a consolidated .NET. So we're going to use that. Doesn't really matter, to be honest. We're not going to do much in this project. You can use whatever version you want. And we're going to go create. And of course, you can do this command line, but I'm just going to show a balance of both because I feel that's going to be best. Now it's going to load everything. Everything's good. We have a project here. So it's going to be pretty annoying, but this is actually the point where I wanted to check in, and we're just going to ignore. Well, I don't really care for today because it's actually not a real repository. Normally you wouldn't check in your OBJ files or your .idea files, but we're going to add project. Oh, and actually you can't see my commit messages, but that's really not important for today. I'm just going to move in here, add project. Okay. So now we have a project. This is basically the point where you would be starting normally. So we're going to go back to our folder here. Now, normally what you would do, or what I should say is, one way of starting from absolute scratch with packet is just going .NET packet init. And what that will do is it will create a dependencies file, which is empty. And you see there's no lock file either. So if I open this up in the code, storage none, there's basically just frameworks here. And we should probably start by talking about what the dependencies file does. So it holds all your packages. It basically defines what dependencies you have in your solution. And so I can go here and go See, this is the thing. You start from absolutely nothing. We have an existing project, and you really have to do groundwork from nothing, basically. You have to write out everything, and that's not ideal in my opinion. So this would be a subpar way to start your solution with Packet. And the other thing you can notice is if I go to my project, I'm just checking if you can see it here. Yeah, there's no dot references file here. So we're missing files here, and if we open our fsproj, we open up in code, you can see it's just what we had before. So we're actually missing stuff here to make Packet work. And so this is why I don't generally recommend starting just by using init itself. So we're actually just gonna remove this and start over. So what we're going to do instead of using packet init, which is, it's definitely a good command and has a purpose, but normally if you're starting from a NuGet, because basically if you're not using packet, you're using NuGet by default. So one thing you can do is instead of using packet init, you use dotnet packet convert from NuGet. So this is going to do a bunch of stuff. And the first thing you can notice is that we have now a dependencies file, which we had before, and now we have a lock file. So if we open up our paket.dependencies file, you can see it looks a bit different, and there's already a NuGet package for us that is F# core, which is a reference you basically have by default if you're writing F#. So that's cool. It does this for us. If we open up the lock file, you can see this is what a very bare bones log file looks like. So it just says here are all the NuGet things, this is where you get it from, and what are the dependencies, and this is the version you're using. And so that's pretty cool. We get this by default. And if I go into my project now, you can see it added a packet.reference file by default as well. And if you open that up, it just says F# core. So it just says the package name that you need to reference, which is, it's nice that it's created by default. And lastly, if we look at the fsproj, you can see it has this directive that I didn't have before. So this directive says, hey, call this packet.restore targets. And that's basically a msbuild command. I don't know if it's a command, but it's basically msbuild code, if you will, so that you can import all the required packages to your project in as a linking when you're compiling. Okay, so that's pretty cool that the convert-from-nuget package does all that for us. So that's definitely where I would recommend starting. Also, of course, you can do init if you want to start on your own or do it from scratch. That's obviously something you can do. And next, what we want to talk about is more in depth of what all the files are in Packet and what are the commands. So I made a high-tech, revolutionary graph to show you everything. And so I'm just going to start with the schematic. And so this is what a solution from a perspective of Packet looks like. You have, at the root of the solution, you have two files, which is paket.dependencies and paket.lock. And with your projects, you have a folder, so basically a folder, and you have a packet.references file. Now, as we saw, the dependencies folder, or file, I should say, what it does is it defines what dependencies you need from NuGet or from GitHub or from whatever sources or artifact source you may require. So if you have an in-house package feed, then you can use that and put your credentials, all encrypted and stuff. That's one thing you can do. What the lock file does is it locks the versions of your dependencies. So every time you restore your packages, you're not going to grab the newest version. That would be very annoying because sometimes there's breaking changes. Sometimes sometimes you don't want to upgrade to a version because there's a bug. There's a lot of reasons why you wouldn't want to upgrade to a new file. And it also lists the transitive dependencies, as I've talked about earlier in the video. And it basically, now we didn't really get to see the transitive dependencies because F#core is just like core library. It doesn't have transitive dependencies. Or at least not to my knowledge, because it just shows up like that. It doesn't have other things. And it probably shouldn't pull other dependencies because that'd just be annoying that your core dependency has transitive dependencies. In our projects, we have a .net.references file, which what it does is it refers to a package in our lock file. So it actually doesn't refer to a statement or a package in the dependencies file. It refers it to the lock file. So it knows what version to get, like I need F#core 5.0. So this is how it refers to it. And anything you put in the references file needs to be in your lock file, or else you'll be told. So actually, we can do that a little quick. Actually, I'm going to go over what the commands are first, and then we'll look into it. And so, okay. So the first and most used command is paket restore. And what that will do is it will look into your paket.lock file for packages. So in this case, we will have F#core. It will download it from the NuGet feed if it needs to. In this case, I probably already have it in my packages, in my user packages. Maybe it'll download it, maybe it won't. If you can force the download of the file if you want, if you force the restore, and it will also update the version in the fsproj files if applicable. So in this case, we don't have an import command in our fsproj. It will actually depend. Some packages have special things that it needs to add in the fsproj, like prop files and target files. In our case, we don't have that. So in the cases where you do have those kinds of files, it will update the version in the fsproj as needed. So we don't really have to worry about that. So what restore really does in our case is just does nothing. Like if I go hit .net packet restore, it does nothing left to do, 0 seconds. It essentially did nothing. Okay, so the next command that's important is install. And what install does is it looks in your dependencies file and resolves the dependencies in your log file. So it looks in your dependencies file, it goes on the NuGet feed and say, okay, I need this and this and this. And then actually before it does that, it actually needs to know what version to get. It has to know, is it a dependency you already have that's a transitive dependency of another dependency? It has all these operations to do before creating a log file. So it goes into your dependencies file, it does like an algorithm, it outputs the dependencies you need in the log file, and then from the log file, I'm not sure if it automatically does a restore or you need to restore after. I think it does a restore. I'm not sure, so I didn't say. But yeah, that's basically what it does. So the operation goes from dependencies to log file. That's the install. And what update does, and very important with the install, is it does not update the versions if it's already in a log file. So that's the way you're kind of guaranteed that you're not going to introduce like new problems in your software. Like maybe like used to work, you change the dependency, now it doesn't work anymore because it like incremented the version and the new version there's a bug. So that's something you don't have to deal with. But in certain instances, you do want to update to the new versions of the dependencies, and that's what the update command does. So the update does an install, but it also updates the versions if applicable. So if there's a new version available, it will upgrade it. Unless, because there's ways you can hard lock a version in your dependencies file, which I'm not really going to go over for now, but that's one thing you can do. There's many things you can do. You can also like group the dependencies together for big files, but I'm actually not going to go into that for now. Okay, so now we have a pretty good idea of how everything works. So for example, if we wanted to add a dependency to use something, so I'll actually go back to writer here, and it's going to print out a message with the string. It's like something very basic. So for example, I'm going to add a dependency to, and then I just want to make sure this is still good. Oh, okay, because this is with that. One sec. Whatever. So I'm going to add a dependency to F#+, which is a library in F#. A lot of people like to use it. It essentially enhances some by default stuff in F#. To put it very simply, so one method it actually has is a method called string. It actually enhances a lot of the string methods, so they can be used and not directly on the string. So let's say message is a string here, so if you do dot, I have a bunch of methods I can use, like replace, for example. But this isn't really the best way to do in F# because type inference works on curried methods. It doesn't really work well on instance methods. So one thing that F# has is it has a method in the string module. It has a method called string replace. So you can see I don't have access to it here. So let's say I'll replace from with to, and then the message. You see it doesn't find it, so we know it doesn't exist. Even if I open F#+, obviously we don't have access to it. So if we wanted to add that dependency, what we would do is you can go .net packet add, and then the name of the package, so in this case is F#+. And if I do this, it won't know what, it will just add it to the dependencies and not to the projects, I believe. Let's just, actually I'm going to, I don't know if I saved this file. I'm just going to check everything in blindly and do whatever. Okay, so if I just do this, I think I'll just add it to the root dependencies, but it won't add it to the project I actually want. So you can see I still don't have access to it. If I look into my packet.references of my project, it's not added here. So that's ideally not what you want to do if you want to directly add it to a project. So I'll just actually added a lot of stuff. So it added it in my packages, obviously. So I'm just going to select all here and do discard. And what I will do instead, and this is kind of whatever, I don't really care that it's there, but I'll delete everything anyways, just to make sure. Control delete. Okay. And so, if you want to add a dependency instead, what you can do, instead of doing add, you can do add-i, and that will be add interactive. So I usually stands for interactive in these things. And so what it will do, I don't think you can see, okay. So this is the command I just ran, and now for every project in my solution, it's going to ask me, do you want to add it to the project? So in this case, I'm just going to go yes. And it does everything that the normal add command does, but it goes an extra step and adds it to the references. So if I go here, it's actually added now, and if I go to my writer, it should, yeah, so now it actually finds the package, and it's telling me I'm not using this value, so I can do actually that message. I don't know if I can, yeah, I'm going to shadow define this. So basically, it's not that I'm mutating this variable, as I'm creating a new variable with the same name, which is, I guess it's semantics at that point. Now if I run this, so I can go just do .net run. Oh, you can't see that either, Christ. Okay, so this is the first time I ran it. It said to F#, and now it says from F#. So I'm going to do it again. This is without the modification. And now if now I constantly have to check if you can see it, because I'm actually zooming in my screen so you can, because one of the feedback I get is the font is not big enough, so I'm just trying to do that. So if I uncomment this, and this just shows I'm actually using the package. Should be 2. There you go. Cool. So that's just us getting another package, defining it, adding it to the dependencies, adding it to the references. A little bit of just the basics of what you're going to do. I'm not going to go too much in depth in this tutorial. I actually think I'm going to end it here, just to get a basic understanding of how everything works. I'm back once more. I realized it didn't show what the paket.dependencies and paket.lock files look like after adding a new dependency. So when we added the F# plus, we added a new entry in our paket.dependencies file, and in the lock file you can see I added this new entry, and what it also did is it added transitive dependencies definitions. So here I need F# core, which we already have, but it says I need at least this, and also needs a system.value tuple, so it adds that dependency. And that's basically it, what I wanted to show lastly. And actually, before I sign off on the computer part, I just wanted to mention what should you check into source control. So normally you don't check in your packages into source control because it's kind of like very heavy, and you wouldn't want to do that. It'd be a waste of time. You do want to check all your packet files in, so the paket.dependencies, paket.lock, and all your reference files. So all of those you want to add in, and as well as the tool manifest, you want to add that in as well. So so basically, when someone else checks out your code base, they can just do .net tool restore and restore all the tools, and just go ahead from there. So I hope you enjoyed this. I'm going to go through the outro now. So peace. Alright, so I hope you enjoyed the video. I hope you learned how to use Packet, at least in the basics. You can always go online and check more documentation if you need help. I also like to announce that I was basically working on my website a lot. There's a big delay, obviously, between my last video. So it's a mix of working on contracts with clients, playing a lot of golf in the summer, and basically taking time to develop my own website. So you can actually check that out in the description. So I offer freelance F# software development and consulting. So if you have any questions or you need help on your F# projects, let me know. And yeah, so I'm looking to upload about a video a week, maybe 2. We'll see how much time it actually takes me, because a lot of the videos actually I take time to plan out what I'm going to do as a tutorial. I can't just go off the cuff and say a bunch of stuff. I actually have to do a little bit of research and do some quality videos. So probably a video a week I can commit to. So if you're new here and like the video, make sure to leave a like and subscribe for more. I really want to invest in making a pretty cool channel for learning F#. So thanks a lot for watching, and I'll see you in the next video.